Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the second lecture series of module 1, Introduction to Aquaculture. My name is Professor Gaurav Bhomik from the Department of Agriculture and Food Engineering, IIT Kharagpur. In continuation with the discussions that we had in the last lecture, I'll share the aquaculture systems and the input factors in this particular lecture. So, what are the concepts that I'll be covering in this particular lecture is the types of aquaculture systems, what is polyculture, what are the significance of feeding in aquaculture, and what are the types of feeds that we normally use in aquaculture systems. So, in general, the aquaculture systems, the systems are classified into 3 broad categories. The first one is extensive, the second is semi-intensive, and the third one is the intensive aquaculture. So, what is this extensive, semi-intensive and intensive aquaculture? I'll share you in later slides. Other than that, the intensity of this aquaculture that we are talking about, based on which these broad categories are been classified, they are actually based on the inputs required for farming. First of all, the fish stocking density. Second is the amount of feed that you need to provide with the time for that specific culture species or whatever the number of species that you are culturing there. The level of manipulation of natural factor. These 3 basic inputs are actually very much responsible for the classification of these 3 broad category of aquaculture systems. So, the first one is the extensive aquaculture. If you must have seen, like we earlier days people used to do the aquaculture even in the developing countries nowadays also, like in India also, we normally do it the aquaculture in a large pond or the large lake, where we not large lake, a small lake and the large ponds and all, where we normally try to provide the seed in the system, introduce the seed into the system. And what happens, because its extensive size, because of all the natural benefits that is available in the system, because of the very low stocking density that all the culture species that we are introducing they have, because of all this reason, what happened, this extensive aquaculture system doesn't need much of an anthropogenic activity. We don't need to involve much, and very minimal inputs are needed for maintaining these fishes growth or the aquatic species growth and the survival. Basically, in case of extensive aquaculture systems, very basic organic fertilizers use time to time, even if most of the cases it's not needed, and even if it is used, it's only the animal or the plant wasted. We simply just throw it into the water body. We don't need any additional aeration, feeding, nothing, because the aeration and feeding, these are the major economical factor that involves with the aquaculture economics, which we don't have to worry about in case of extensive aquaculture. It has a very low stocking density, as I already told, generally less than 500 kg per hectare, hectare 10,000 square meters. So, other than that, the natural productivity of the feed, like the plants and the animals within the system, is actually used for whatever the culture species that you are producing there or culturing there. Another important thing is as I already told, the aeration is not needed because the natural gas exchange is happening. From the atmosphere, whatever the dissolved oxygen that is required for the culture species to survive in your system, in your aquaculture, extensive aquaculture systems, it's ample enough. So in general, we do not have to go for this additional aeration cost and aerator installation, in this kind of extensive aquaculture systems. They are normally used for pond farming, bivalve, and the seaweed farming in general. The second is the semi-intensive aquaculture. In this particular type of system, it is not extensive, like it is not completely rely on the natural productivity and the supplementation, but it rely up to an extent on natural productivity and supplementations. And additional feeding or additional aeration is provided only if it needs. Okay. So in that particular case, we call it semi-intensive aquaculture systems. So there are provisions that you have to ready with, so that you can provide the aeration system. You can start the aeration if you think like your culture species is struggling with the available oxygen, or you can just provide the aeration time to time basis to maintain the dissolved oxygen level of your tank or of your culture unit. Addition of inorganic or organic fertilizers to improve the natural productivity. Addition of prepared food. It's called supplemental feeding. It's not that is very much necessary and you have to provide each and every day. It can be very the duration for alternate feeding can be very high. You can even not do that if you think like your aquaculture system has ample amount of natural feeds available for its survival. It's almost exclusive to ponds, and it allows for an increase in the stocking density within the pond. So it's not something that we normally target in the tank or the raceway systems. The third and the most productive one, and also in ways it was one of the notorious one at one point of time, but now with thanks to the advancement in the technology, now we have cracked that the problem that the major issues that we were facing with this intensive aquaculture. This is actually completely contrast to the natural systems. It has a very simple food chain. You provide food, then only your culture species will survive, then otherwise not. So there is no hierarchy in the food chain in this particular type of aquaculture systems. It can be these intensive systems maybe in the ponds, example shrimp in the tropical and subtropical regions, cages in the marine fish farming, the raceways in the temperate regions, they go for trout species, culturing of the trout species, they do it in this intensive aquaculture systems. In the tanks, in Japan, they produce eels in the tanks. So that also this production of eel is actually they producing in the intensive aquaculture facilities. All the nutrition in this farm stock, it actually comes from the introduced feed, and no utilization of natural diet is at all present in this kind of aquaculture systems. Very high stocking densities are practiced with a very higher productivity and the yield. However, it comes with a lot of additional issues and a lot of additional economic involvement. So that I will be discussing in later slides. So in general, if you compare like the intensive aquaculture in pond, intensive aquaculture in cage, or intensive aquaculture in raceway or tanks, the stocking densities are lowest in pond, followed by cages, and then the highest in the raceways and tanks. Because in raceways and tanks we have more of a flexibility to control the environment, to make up optimal situation for your target species to survive there. So once you have that control in your system, for your target species to survive in your system, then that's why the stocking densities are very high in these cases like in raceways and tanks, whereas in case of ponds it's very low. As I discussed, the characteristics of intensive aquaculture, the very basic one is like it has a very simple food chain. Just prepare food, supply it, your organism will survive. Otherwise, they don't have any other source of food in your systems, because your culture density is very high, stocking density is very high. if you want to have a good amount of production, you have to go ahead with the preparation of proper amount of food and supply that food, that particular feed to your cultured organisms time to time, and you have to take care of that feed demand for your cultured organism in your system. In general, the low energy losses from the feed input with high food to food conversion ratio from specified artificial feeds can be achieved in this kind of culture systems. What does that mean? Suppose you go for extensive aquaculture or say semi-intensive aquaculture systems. In extensive, you're not going to put any feed, right? But in case of semi-intensive, you can put feed. You can put feed time to time, supplemental feed if it requires. But whereas you cannot be sure about the food or the feeds or the feed that you are providing, the nutritional the benefits that it has, whether it is actually transferred to the the person who is consuming that fish or not. What does that mean? And also, like, see, first of all, the fish, it has to consume that feed, so that fish, this food conversion ratio has to be very high. That fish that food has to provide ample amount of nutrition for that fish. And then there comes another type of food conversion ratio that we consider, that is not the thing that we are talking about here. But in that case, we also talk about the how that biomass that is present in the fish are actually being utilized when we assimilate that assimilate that particular culture species or not. Anyway, so in this particular case, what we are talking about, the food conversion ratio of feed to the fish biomass or to the culture species biomass. Okay. So because of this specialized artificial feeds, this ratio can be very high. Earlier days, like like people use natural even like seaweeds. Earlier they use the normal seaweeds. They simply put it into the system and then try to make it use as a feed for some particular type of species, aquatic species. Later on, they find out like why to utilize the seaweed. Let's go for, they dry it, they make a proper feed out of it, they make it in such a way that the ultimate product is very, like, they can consume it much better. This conversion ratio for their ultimate biomass is, like, fish biomass is very high if you can make it in a specialized way, and then you supply it for as a feed. Okay, so it's just an example that I'm giving. Like, so this kind of scenarios we were facing earlier days, but now still research is going on to make this fish feed in this in a proper proportionate way, so that it can be highly beneficial for the target species that you're culturing in your system. Okay, so in case of intensive aquaculture, no recycling of energy at all, and it's totally non-self supporting. What does that mean? It completely depends on the high input of energy that you are providing to the system. Because see, it's just a normal stagnant water body, or say like a running water body where there are some culture species. That's it. They do not have any other resources to utilize. So where from they get these resources? Artificial means, by means of our anthropogenic activity. Like we provide them feed, we provide them aeration so that the dissolved oxygen level will be higher. We provide them with the filtration technique so that whatever the wastewater that is generating from the system can be filtered. So this filtration system also you have to provide, because unless until you filter the water and you use it, the aquaculture species, they will be in stress. First of all, they will be in stress for time, because they cannot sustain more ammoniacal nitrogen or any nitrogen species present in the aquaculture pond or aquaculture tank or space, whatever you are using. So they will be in stress, first of all. Second, they will die at the end. If it goes up to a certain extent, they will die. So filtration unit is one of the major factor that plays a major role here in aquaculture sectors. Otherwise, what you have to do, you have to get rid of the water, you have to go for freshwater exchange, and which comes with a lot of price, because you cannot, freshwater does have a huge price nowadays, because freshwater doesn't come easily. So especially if you talk about the rural urban areas, if you want to have your own farm, aquaculture farm in the, say, like near in urban or say like semi-urban areas, the water cost is very high. So you cannot just think of doing all these aquacultural activities, aquaculture sector development, unless until you come up with some advanced solutions. So I'll discuss about all those solutions in later days, and I mean later lectures, where I'll show you like what are the advanced technologies that is developing by the scientists all over the world to treat that, to improve these filtration units and to treat that wastewater, so that this freshwater exchange consumption is very, like, it comes down to almost zero nowadays. There are pumping, because definitely, like, when the freshwater exchange is there, there must be somewhere the source is, and you have to use the pump to get the water from that source and to utilize it in your aquaculture tank. So what is the major advantage? Why still people are looking for this intensive aquaculture system is the high yield. It has a very high yield per unit area or unit volume of the aquaculture tank that your aquaculture tank or the raceway that you are culturing or pond that you are utilizing. So because of this high yield, it comes with the very high economic benefits as well, right? So once it comes with the benefits, it can easily surpass all the requirement, all the economic requirement that it has, the inputs that it has for the energy or for the supply chain and all. So it can easily, we can easily neutralize this demand, and not only neutralize, we can somehow improve the amount of yield, and we can get a economic benefit out of this kind of systems. The next thing that I want to discuss about the polyculture, I think we don't go for single culture anymore, because in order to utilize the whole pond system, because see, first of all, there are different type of aquatic species. They have different zone of dwelling. Okay, what they do, like, there are type of fishes who prefers to stay in the surface of the water body, and they only go for this larvas, they go for this the phytoplanktons and all. There are some they can be even piscivorous as well, but there are some type of fishes or aquatic species, they normally try to dwell on the column or in the middle zone. We call it we call it column dwellers. Okay, so in the column dwellers are there who try to stay not in the surface, not on the bottom, but more in the middle zone, middle area, like the column area we call it. Then there come the benthic zone, which is like almost on the bottom of the tank or the pond, where there are some dwellers who love to stay there and love to have fed by the they normally fed there in the benthic zone only. So if you go for a culture system, if you go for developing a farm, aquaculture farm, you definitely want to utilize all these sectors, right? You don't want to go for a culturing a species which will only stay in the top. Whereas you can increase the productivity, increase the yield if you can start doing 2-3 culture species culturing together, and let them have their feed. They will not interact with each other's feeding habitats, and they don't go for there will be no conflict in feed for this kind of species. Not only that, there are fishes who loves to have phytoplankton, who loves to have zooplankton. Some of them likes to have the aquatic insects, some of them likes to have the aquatic organisms or the detritus in the benthic region. Some of them are only herbivorous. They only likes to have the aquatic vegetarians present in your culture system. So based on this, all these requirements, all this you would just go, before you target your culture species, you try to understand their habitat, you try to understand their food habit, you try to understand what they prefers, where they prefers to stay, what kind of water, what kind of food requirement that they have. Based on that, you go for a deliberate farming practice where you increase the yield like anything. Okay, in a same water body, go for polyculture, increase the yield of the same water body that you are using in earlier time by just utilizing a proper science. You use the science, you utilize the more amount of species in your system, and make a maximum yield out of it. So that's how this polyculture works. So next thing is the feeding. Why feeding is important? Like in especially in case of extensive aquaculture, we don't have to worry about it because it's naturally being taken care of. In case of semi-intensive and intensive aquaculture, we have to take care of the feeding. So first of all, if you want to have a high quality produce, healthy produce, you have to have a good quality feed. You have to supply them with a good quality feed. It's simple enough. Good nutrition in the animal production systems is very much essential for the proper economic production of a healthy and high quality production or the yield for your system. It's a very well known fact. Second thing is like this nutrition is critical because this feed, the amount of the cost involved with this feed, actually it accounts for approximately 50% of the variable production cost of any farming systems. So unless until you have a proper nutritional balance you maintain in your feed, unless until you have cheap systems available, like low cost but sustainable systems available for production of the feed, or at least the supply of the feed in your system, it can cost you a lot. It can not only cost you a lot, it involves with everything. Good amount of feed gives you good production, good economic benefit also. So it's not always that if you go for cheap food and cheap low cost food and low cost nutritional the input, if you give to your fish, it will also give you the low income, it will also give you the low yield, and which comes out as a not beneficiary at all. So this is very important. Fish nutrition, it advanced dramatically in the recent years, in the last couple of decades, and it now the new balanced commercial diets are available which can promote optimal fish growth and optimal fish health all over the world. So let's talk about the type of feeds that is available. So normally there are three types of food used in fish ponds: natural, supplementary and complete food. What is natural feeds? So natural feeds, it includes the detritus which normally stays in the bottom of your tank or pond, whatever it is, bacteria, it can be suspended one, it can be attached growth ones, whatever it is. There are planktons, it can be phytoplankton, it can be zooplankton, worms, insects, snails, aquatic plants, fish, etc., etc. Why I am talking about fish as a natural feeds? Because fish can be feed for their higher chain fishes as well, or other higher chain aquatic species as well. So they can also be a feed. They are also a natural feed in aquatic systems. Their abundance greatly depends on the water quality. It's definitely because suppose in case of natural feed, when we are talking about, if suppose you are having a offshore culture, or say if you are having a cage culture in a brackish water, where it's like the river mouth, where river is, or the estuary region where the river is actually reaching the sea. In that region, it's very rich in nutrient, different kind of nutrient. Why? What is the reason? Because it is coming down all the way from the mountain and washes out all the possible things from the villages, cities, or whichever it passes. So at the end, when it reaches the sea, at that moment, at that river mouth, they have a huge amount of nutrition present there, and this huge amount of nutrition actually demands like it actually it's beneficial for different type of varieties of aquatic species. You can see they dwell there because they love to have the abundance of food is already available. So it depends on the water quality and depends upon the place where you are culturing your things. First of all, if your water quality of your culture species, suppose like if you are having a same pen culture, same cage culture in a same brackish water, but it is coming from the wastewater, it is near to a river mouth, where the wastewater from the local municipality or the local industry is actually pouring. So that wastewater has, say, like different kind of xenobiotics, different kind of unwanted endocrine disrupting chemicals and all. What will happen? These chemicals will affect your yield, because definitely your cage culture, whatever the species that you are targeting there, it will not survive there. It cannot survive there because of the higher amount of the pollutants that it receives. So natural feeds, it depends on the water quality as well. In case of supplementary feed, we normally provide it to whom? In case of semi-intensive one, right? In case of semi-intensive one, what we do, we provide it with terrestrial plants, kitchen waste, agricultural byproducts, but make sure it doesn't contain any chemical fertilizer or chemical pesticides. Whatever the byproducts I am talking about, it should be organic in nature, supply to the to your tank or to your aquaculture production. it will be very much healthy. It will make a very healthy ecosystem in your pond. The third thing is called it comes the complete feeds. Okay, complete feeds are the one which you have to have in case of intensive aquaculture systems. You have to. It normally made from a mixture of carefully selected ingredients to provide all the nutrients necessary for your aquatic species to grow properly, healthy and well. So this is actually target specific, target species specific. Why I say target species specific? Suppose you are culturing, say like bivalve. For bivalve, you don't have to worry about feed at all, not much. Say you're culturing any others other than fish. You're culturing some say like any small fishes and all. Okay, so when you're culturing any small fishes and all, they have a very higher feed requirement. Okay, but their feed has the size which is good enough for them to swallow or for them to utilize them to have it. You cannot have a system, or you cannot have a fish feed, you cannot have a fish feed which is not sufficient enough, which is not you don't have the ingredients which are good enough for them to have it, and unless until they will have it, they will die, and definitely it doesn't make sense to provide this kind of things. So this must be taken in the form so that the fish they find it easy to eat and digest, and difficult to make, and the form, and it's sometimes quite expensive in general, this form. As I discussed about this natural food production, in general, natural fish foods present in the fish pond are very diverse, usually consist of a complex mixture of plants and animals. They range from the microscopic to the relatively larger size. Fertilizer of ponds, we normally go for this fertilization sometimes, time to time. It's not something that we are introducing a feed or introducing a fish feed to the system. We are actually trying to fertilize the system. So by means of fertilizers, it's like sometimes we introduce some iron based compounds. So what it will do? It will help to grow the phytoplankton in the system. So once it will help to grow the phytoplankton in the systems, it will definitely helpful for all the phytoplankton loving and aquatic species, or say like zooplanktons, which are actually in the higher tropic in the supply chain in the food chain. Then accordingly the whole system will evolve, whole system will be beneficial out of it. So that is why sometimes we can provide the fertilization, we provide this to boost the biological cover in the ponds. The second thing is supplementary, that I already told you. It's like it's incomplete or the partial diet, which are intended only to help to support the natural food which is already available in the pond, and so that the fish will not feel feel in stress that they don't have ample amount of food available for them to survive. It normally fortifies the naturally available diet with extra protein, carbohydrate and or lipids. When to use supplementary feeds? When you see that it becomes insufficient, the natural foods are insufficient at that particular moment of time to ensure proper fish growth or proper aquatic species growth. At that moment you have to take care of it, and you just go for supplementary feed. You just need to supply it. You have to do it continuously monitor your farm, and you have to make sure that the fishes are not in stress, and if it is, then provide them with the natural foods. When the stocking density is very high and the good growth is required, at that moment of time also you have to provide them with the supplementary feed. So suppose you have a very specific amount of, say like 100 kg per unit area, you have a production, and all of a sudden you think of having, like, due to market demand, you increase it to the 200 kg or say like 300 kg per unit area of the pond or the tank or raceway that you have. When you try to increase it to this 2 or 3 times, you have to supply it with this supplementary feeds. So what are the desired properties of the supplementary feed? It has to have a high protein, carbohydrate content, very low fiber content. It should be year-round availability should be there with minimal additional cost for transport, handling and processing. It should be cheap in price for given food quality, and lower the cost is better, obviously, from the economic point of view. It should be well accepted by the fish you plan to feed, because for them it's a sudden feed. It's like their faced. All of a sudden you providing them with the new food and all. But if you suppose who doesn't like that particular type of food, if you supply them, they will like, no, I'm not going to have it. Like they will not find it cozy and they will not find, they are not going to have it, and that doesn't solve our purpose. And also it has to be easy to handle and store. So the way forward, the complete feeds, that's the future. So you have to, because especially because we'll be talking about the intensive aquaculture all lecture long in the coming lectures also, where we'll be discussing this complete feeds. Complete feeds should have all the ingredients: protein, carbohydrate, fat, vitamins, minerals, like at a particular ratio which is very much beneficial for the optimal growth and the health of the fish. Most of the fish farmers, they use the complete diets, typically made up of the following components, like the protein has to be around 18 to 50%, lipids 10 to 25%, carbohydrates 15 to 20%, ash content less than 8.5%, phosphorus content less than 1.5%, water try to make it less than 10%. I'll discuss about it in later slide, like what is different type of fish feeds and all. There are type of wet feed, there are type of moist feed which has a high water content, can be as high as 30-40% as well. They are also doable. People are using those kind of fish feed as well. And obviously trace amounts of vitamins and minerals which are beneficial for your target species that you are culturing there. The nutritional content of the feed, it depends on the species you are culturing and its life stage. Definitely it depends on the life stage. You're not going to give a when it's a fingerling amount of food that it requires for its adult stage. So most of the feed will go wasted and it will cause the environmental harm, nothing else. Okay, and the wastage of money. So complete fish are required when we want to rear high density indoor systems and where natural food is completely unavailable. So these are the references that we use while preparing these slides. You can go ahead with studying these papers and these research papers. If you need, I can share you these slides, this lectures, research papers as well with you. So for you to have a better overview on the system and all. So that's it for the day for this lecture. Thank you so much.